Ethereum. So basically, moving forward, we should have some idea how the Solidity language, where the Solidity language works, and so on. So as you can see here, like this one is Web 2.0 model. So in Web 2.0 model earlier, there is a HTML is used as a front end, and there are back at the back end side there is Node, Python, Java, Ruby, etc. And also there are storage like MongoDB, Firebase, MySQL, and so on. So whereas in the case of the blockchain model, where we use Ethereum as means we may use any type of platform like Ethereum or Polygon or Solana as a databases. So this one is work as the DB, okay, and this one is the like traditional database system. So here we use Ethereum blockchain as a database. So as the front end, the front end will be again the same in the Web 2.0 and Web 3.0. So in HTML, JS, CSS, React, nowadays React is popular, so you may use here the React also. Okay, and in backend we use the Solidity compiler that compiles the smart contract. Solidity is the language, and the code written in the Solidity is known as the smart contract. Okay, so to communicate with this blockchain model, so this one is one blockchain model, and to communicate with this blockchain model, we should be work like a node, like Infura or any Quick Node or any Alchemy is these are the providers. So which provides us a environment like we are working as a node. So in blockchain network, when we communicate with the blockchain network, so we should work as a node in the blockchain network. Okay. Okay, so next is Solidity. So basically, the Solidity language is designed to write a smart contract in the Ethereum blockchain platform. So Ethereum is one blockchain platform. So one is Bitcoin. So in Bitcoin is one application of the blockchain, and one more is the Ethereum. So Ethereum is again one application of the blockchain based on the blockchain. So in Bitcoin, only the cryptocurrencies can be the transfer of cryptocurrencies can be happen. So there is only single piece of code that is only be used for the cryptocurrency or the financial transactions, where in the in Ethereum, uh, you can write your own smart contract. So you may write your own application like for the supply chain management, for e-voting system, for managing the healthcare data, and so on. Okay. So this Solidity is a statically typed language and also object oriented programming language. So it's like JavaScript, Python looks like JavaScript, Python, and C++ variable name are like that. C++ int, bool, and so on. We will see how we define the variable in the smart contract. So this language is used to write all kind of programming logics in the uh, all kind of programming logic in the Solidity language itself. So this is its language is called as the Turing complete language. So we have Ethereum virtual machine on which we run our smart contract. So Ethereum virtual machine runs on all the nodes in the blockchain network. So for example, in a blockchain network, if there are 1000 nodes, so each and every node will participate in the Ethereum virtual machine. So they will share a same core, their same smart contract that is deployed on the blockchain network. Okay, so this one is a basic structure of the blockchain. We have to define which compiler compiler we are using here. So here we are using 0.6.12 to 0.9.0. So this one is this provides backward compatibility Okay, so we have to write any contract with the any name. Here the name of the contract is my contract. Okay, so this one we'll write now one single simple smart contract named as storage dot soul. So here the soul is the like extension of this solidity language. So we have to write our code in this any code file with the extension of the .sol with the name storage. Okay, so or for the example, we will store the value in any variable and then we will retrieve the value of that variable. So in this is as written here, we are using here 4.0.4.24. So this one is the compiler version. Okay, and contract name is my contract. Here we are taking one variable named value, and the data type is string with data type. So this variable is a state variable that is accessible throughout this smart contract. So this variable is known as the state variable. So this value is stored in the blockchain itself. So to storing to storing the data into the state variable, we have to pay the fees. So the stored state variable is costlier with compared to memory type. So in this blockchain, there are storage type and memory type. We will discuss what is the storage type and what is the memory type. So basically here we have declared one variable, a string type variable named value, and that is a state variable, and that will persist in the blockchain. That will persist in the blockchain and that will persist in the blockchain for a permanently. Okay, so next is this one is the semantic versioning here. So if the version is 0 point x point y, and if there is any change, then the new version will be x point z. So if z is greater than y, then the x point z is backward compatible with the x point y. Okay, so we have to write our code in the solidity, and then we have to come after compilation of that code, we have to deploy the smart contract to the blockchain. So new version with respect to time, new patches and new bugs, when we encounter any bug in the solidity language, then new patches and new versions are introduced that contains some breaking change, or some there may be some light version changes. So the uh, best IDE to run the Solidity smart contract is Remix ID. We have already discussed in the earlier session that Remix is one IDE that is used to compile the smart contract. Although we can install our offline compilers, but Remix ID is easy to use, and the packages are mostly available here. So I'll show you how to use this Remix ID. So first, let me change the screen. So stop sharing and then screen cancel. So share. So I have shared the is this screen of the Chrome tab visual to all of you. Please reply in the chat box. Am I going right or not?
Yes, sir, it is visible.
This one is Remix ID, na?
Yes, sir, Remix ID, it is visible.
Okay, okay. Thank you. So I request Mr. Agam to be here. The reason is like this one is going to be interactive and hands-on lab of session. So I'll need your help during this session. Okay, so this one is the Remix ID in which we'll write our code and we'll compile our smart contract. Okay, so here from starting from scratch, this one is if I write here Remix ID. Okay, so leave this site, and this one is our visualization of this Remix ID. So first, when I write remix.ethereum.org, then I will get this view. So first, we have to write one smart contract here. So there are some sample smart contracts given here. Storage.sol that is already given for the testing purpose. Okay, so this one is storage and extension is Sol. We also can add our own smart contract like test.sol. Extension is Sol here. Okay, so I have some I have to check like mm, yes, Agam, is this remix ID is sharing or something else is there?
Remix ID,
Oh,
test.sol.
okay. So let me take one example from my database. Is like that is of pre-written code. Okay. So okay. So I have one means I have wrote one smart contract that is of name is simple storage smart contract here, and we are using one private variable and the data type is you. We will discuss all the data types available. This one is the basic glimpse that how to compile the smart contract, how to work with the smart contract. So I have written here one variable integer type, unsigned integer type, and the size is 256, and the name is storage number. So there is one constructor function, there is one set function, and there is one get function. Okay, so this one is basic simple smart contract in which we are setting the value of this variable, and then after that we are getting the value of this we are fetching this value of this storage stored number. So and this one is one contract this one is one sorry this one is one constructor. Okay, so we may use either this we may test with the given already given test code, or we may write our own code in this ID remix ID. Okay, so next is the compilation of the smart contract. So how to compile the smart contract? As written here, we are using 0.8.0. So compiler, I have selected compiler 8.3.0. So this compiler should be greater than this given compiler, because all the compilers are backward compatible with the previous version. Okay, also sometimes it may be happen that if there is a larger change in the new version, then we have to exactly use this compiler. Okay, so this one is the compilation in the third in the menu bar in the third icon of the compiler. So we have to compile with this compiler version. I have to click on the compile smart contract. So as shown in the terminal here, as shown, I have compiled this smart contract, and here is the tick sign. It means the smart contract is compiled correctly. Okay, now this now when we compile this smart contract, two types of I have discussed two types of file will be generated. First one is bytecode and second one is ABI code. So we have to deploy our bytecode to the real-time blockchain. So this IDE provides us virtual environment, Remix virtual environment, virtual machine. So there are several virtual machines. You may choose any of the virtual machine like Remix VM, this Pragyo, this one is Kunen and Mainnet, Fork, etc. So I have selected this VM virtual machine, and we have discussed that like again I have to switch to the another screen. Okay, so mm, share, stop sharing, edition, and then Windows and this one. Okay, okay, so I think I am taking just a plain sim window. Is this visible to all of you?
Yes, sir.
Okay, so okay, so as we have discussed, like in the earlier diagram, there will be multiple nodes, okay, who will initiate the transaction, and one node contains multiple account addresses. Okay, one user means user one. There is a one user, I think that draw is like the one user contains account one, account two, account three. Okay, so you may use any of the account to add the transaction to the chain of the block. Okay, so this one is the blockchain. So any user can use any account to initiate the transaction to the blockchain itself. Okay, so now okay, so there are multiple accounts given here. Each and every account is having 100 ethers. Okay, so for initiating the transaction, we need the ether. Okay, so this account contains these all are the dummy ethers or the test ethers. Okay, so if I choose any account, okay, so if I choose this account and then I initiate, means estimated gas, means how much gas will be costed to me to deploy this smart contract to the real blockchain. Here we are using virtual environment. So we will deploy the smart contract to the virtual blockchain using this account address, and estimated gas will be, means this compiler will suggest the estimated gas. Otherwise, we may define our custom gas also. Okay. Custom, the purpose of this custom gas or the estimated gas is like, for example, like if I define here custom gas, then up to this limit I am willing to pay this much of way. This much of way, way is the uh, unit of the ether, means unit of the currency. Okay, so I choose this much of way to deploy a smart contract. If the of the smart contract cost of the smart contract deployment of the smart contract is higher than this cost, then this deployment will be rejected. Otherwise, if the cost is within this network, sorry, if the cost is within this range, then the smart contract will be deployed. So why we use this custom range? The reason is like if we are willing to pay this much of amount. So this one is again one security constant is like here, like up to this amount the cost will be beared by this account user. Okay, so we'll select here estimated cost. Okay, and I deploy the smart contract. Actually, in the smart contract there is one constructor. If you check out the smart contract, so there is a simple smart contract having one variable, that is private variable. So there is three functions. First one is constructor, second one is to set the value, and third one is to get the value. Okay, so constructor is called when you deploy the smart contract. Here the constructor is taking one argument, that is initial value argument. So we have to pass out this initial value argument to deploy the smart contract. And this is mandatory. If the constructor is defined in any smart contract, so then it is mandatory to store the, it is mandatory to pass the value in this argument. So when you hit here the deploy, then here given here input required. So we have to write here any input, that is like for example 1 2 3 4. Basically the value we are passing here 1 2 3 4, and when we click here deploy, then the log file is generated here, like this contract is means deployment of this transaction, the deployment of this smart contract is done correctly from the account. I ask one question, like is the values are visible to all of you? You may write here. I think you may write in the chat box, is the value written on this remix id is visible or not? Is this value transaction is visible or not? Transaction has and this address. Please reply in the chat box. Okay, okay, thank you, Ayush. So what we are discussing here is like I am sending the transaction. Earlier here was 100 ethers, and I have sent the transaction with 5B3 and so on. Okay, and so when we check out this log file, then the from the account address 5B3, both are the same. Okay, so I am sending this transaction from this account to simple storage and with the constructor and with some value. Okay, so the transaction hash is given here, block hash is given here, contract address. So this one is the contract address to address, and this one is the for from address. Okay, so here D9145 and so on. So this one is the in the hexadecimal, or the size of this address is 256 in bits. This one is bits, means in binary words, in binary digits. So this one is 256 bits of the contract address and 256 of the sender address. So we have earlier discussed that there are two types of account address. First one is user address, and second one is externally owned account. Okay, so the gas cost is 163693 gas, and transaction cost is 142341. This one is transaction cost. Okay, so this one is the log file, and this one is the output of our smart contract, and the input is like we have given here, input is 1234. Okay, this one is decoded input. Okay, we communicate with the ABI, uh, we communicate with the ABI file. Let me switch the screen first. Okay, so okay, okay, so when we compile the smart contract, two files are created. Okay, so first file is ABI file and second is bytecode. So with the help of ABI, we communicate with the bytecode. The arguments are passed, arguments are passed in the form of ABI. Okay, and we are passing 1234 as an input. Okay, so this one is the way how to compile the smart contract. Okay, so this one is the compilation of the smart contract. Smart, what is a smart contract? Smart contract is basically one application program. Smart contract is basically one application program in which we write any agreement or any tender or any piece of application and so on. So we have wrote here one application program that stores some value and then we retrieves the value. So in Bitcoin, there is single application that is only for use for the financial transaction. There is a cryptocurrency named Bitcoin. Okay, so we can work on only Bitcoin, but Ethereum, in Ethereum we can write multiple applications, either financial application or supply chain or e-voting or medical and so on. Okay, so here this one is the storage of the data. So the storage of the data either may be numeric value or it may be string value. So this one is the like we are using here remix ID. There is injected provider MetaMask is given here in the environment. Okay, so in which environment we are deploying the smart contract, either in the virtual environment or in the test network or in the public network. Okay, so when I select this this icon will you may test this remix ID on your laptop along with this presentation also. Okay, so you have to write just remix.ethereum.org, then there are some sample test codes. You have to choose one test code and then you have to click on the compile. I compile this test code and then you have to deploy this smart test code. So for this injected MetaMask, this injected MetaMask will not appear in your Google Chrome until unless you did not add the plugin. So here this MetaMask plugin is added in my device itself. I have created one account in this MetaMask here. So I have already created one account in the MetaMask. Okay. So there are mainnet, testnet. These are the test networks. These are the mainnets. So these are Solana mainnet. This one is Ethereum mainnet, Lena mainnet. and there are some additional networks, there are some test networks also. So we have to use the test network, because if we use here the mainnet, if we use here any mainnet, then in that case we have, actually I have zero balance in my mainnet. Okay, when I select this Ethereum mainnet, so my Ethereum portfolio means real time cryptocurrency, I have null cryptocurrency, so I can't use this account to initiate the transaction. If I have some money in my account, in that case, if I select this mainnet account, so by using my mainnet account, I can initiate the transaction. So what I have to do, I have to use the test network, so that I can, if I have some money in my, means I have some ethers in my test network. This one is Sepolia test ether test network. So these are the Sepolia ethers I have in my account. Okay, so I have selected here injected MetaMask. When I select this injected MetaMask, you will check now my real Sepolia ether are showing here. I have only single account associated with my. Is this plugin is also visible to all of you or not? Actually, I have shared the screen. Is this plugin, Remix plugin, visible or not? Remix plugin, na? Okay, okay, then fine. Sorry, MetaMask plugin. Sorry, MetaMask plugin. Okay, so this one is MetaMask plugin here. So I have my account address is, when you check out this account address, this one is A7194. Okay, and when I select this injected MetaMask with the Sepolia test network, and I account address is this, so I have the account address is also displayed here, that is A71 and so on, with this much of ether, 0.603 ethers. Okay, so I have selected this. Okay, and now I am trying to add this smart contract to the public test network. This one is the public test network. So when I deploy this smart contract with the value 1234, and I click the deploy, so the this one is creation of the smart contracts in the log file given here. From account address, from is like sorry, which one is, so creation of the smart contract is pending here. When I select, I get a request from my browser that deploy a contract, and the cost of deployment is like, this one is the network fee, speed of the network is 12 seconds. So I have received the request from remix.ethereum.org. Okay, so when I click on the confirm, so after that, after some time, because there will be some mining time that will be consumed, means there are some mining time. When we initiate the transaction, transactions are added to the pool, and the miner fetch the transaction, validate the transaction, and then there, after the verification of the transaction, the block is mined. So here in the Etherscan, average mining time is 15 seconds. That varies from application to application. So here this block number with this transaction index, when we debug this code, so from address is like A7 and so on. Okay, and this one is the contract address. Okay, so this one is the contract address. We can access this contract on the Etherscan, uh, Sepolia, Sepolia. Uh, okay, so Sepolia Etherscan is here. So I have to change the sharing mode of from Remix ID to testnet. So I have to switch, stop sharing, and then screen, and then uh, testnet Etherscan. So now I think one, which one is visible to Etherscan? Let me change. Yes, that's the correct. Okay. Okay. So here, this one is Sepolia. We have deployed our smart contract to the Sepolia test network. So our smart contract should be here. Okay. So when I check out my address from which account I have deployed the transaction, so when I check this transaction confirmation, so I have sent this from my account address. When I search this, okay, when I click on the this my account address and then click on search with the my address, so I think means our transaction should be here. So in blockchain, every transaction, either contract deployment or like either contract deployment or like initiation of any data storage or like transaction of any money, each will be called as a transaction. Okay, so 2 minutes ago we have deployed one transaction. This one is the transaction has, and from account our address is A7196 and so on. This one is out kind of contract creation. This one is the transaction fees. So when we see checkout here, so this one is the detail of our transaction we have performed here. I have paid the gas to execute the transaction is like 1.53 times 076919919. So this one is the when in ether, this one is this much of ether. Okay, so with this block I have created one transaction in this block. So this block will contain the multiple transactions. Block height is this. So when I check this block, so this block will contain multiple transactions here. When I click on this one is the block address. Block, this block contains 174 transactions, in which there is one transaction that is R. Okay, from A7, whatever is the address of the transaction. Okay, so here as shown here, 174 transactions are there in this block, in which one transaction is R transaction. Okay, so what happens exactly, like multiple users initiates their transactions. The transactions are clubbed into the pool, and miner fetches those transactions, a bunch of transactions, and then validate those transactions and then participate in the mining process. When the transactions are mined, then that block is means that block is mined, that block is added to the blockchain pool, blockchain real working blockchain. Are you getting this content or not? I'm not sure. Actually, this one is one-way communication. So you may write in the chat box if you have any doubt during this session. So we may cover accordingly. Okay. So next thing is like we have checked our transaction using the Ether Sepolia etherscan.io. Okay. So this one is our remix. Let me change the screen. Stop screen, and this one is like remix ID. Okay. Okay. So in remix ID, what we have discussed here is like we write our smart contract in this terminal here, in this online browser. Okay, so we can compile our smart contract with the help of this compile icon. We can deploy the smart contract with the help of deploy and run transaction. Either we may use any virtual environment, or we may use any injected provider, that is MetaMask here, or we can add our own custom we can add our custom blockchain here. So if we install Geth, and we can create our local environment and our device itself in our computer system itself, then when we start the local host server on our laptop or our desktop, so our local server will be displayed here. So we have to select this local, means there will be the server of name will be here, and then we will select that local host, that will be our server. Okay, so that will participate in the mining itself. So our device itself will be a node and will participate in the mining task. Okay, so you may also use hard hat or the foundry. Hard hat and foundry also provides the blockchain environment. These are the framework to deploy the smart contract and to test the smart contract. Okay. So compilation has been done, deployment has been done. So the value of this ether will be reduced when we deploy the smart contract. Okay, So you may use any type of environment in which you are willing to deploy your smart contract. Now come to our presentation where we'll discuss this variable types, how to write the smart contract and so on. So as shown here, this one is there are the like function name is set with one input argument with the visibility public and with this we'll we will first check out what are the variable available functions here and what are the variable data types, how to write the data type and so on. Okay, so let me change the screen from web to presentation. So application and that is PowerPoint. Okay. So I think now, okay. So now in this slide here, you may manually install the Solidity compiler with the help of with the npm network package manager with the command npm install. Then with in -g, that is the in the global environment, and using the command sol c. So you can install the Solidity compiler in your laptop itself or desktop itself, and then you can test your smart contract instead of using the Remix IDE. But to create the environment and to learn for the learning phase, the Remix IDE is okay. For the learning purpose, that is okay, but for the advanced projects or advanced state, you have to install this manual Solidity compiler. The reason is like there are multiple header files, there are multiple library files, header files that is installed in your compiler itself, and the task or the compilation time will be reduced, and that will be easier to you to manage all each and every file in your desktop system itself. Okay. So I think I have to create erase each and erase all of the slide. Okay. So so I have creating here function get function. Function name is the get function that returns the value. Okay. Function is get function and means there are two types of we are setting here get function and the set function as we have discussed in the example. So get function returns the value. The return keyword is used to return the value here. If we use the public keyword here, if we use the public keyword here, in that case, I think please let me please clarify that is the PPT is available or not. Is I have shared the PPT. I am working on PPT now. Only PPT is there or something else?
Sir, it is showing a slide named Simple Smart Contract
Yes.
Function.
Okay. Okay. That's fine. 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 Then fine. Okay. So I have said I have written one function, get function with the visibility public, and that is of the view kind, and that returns the string. That is the return type of this function. Okay. So this returns the value. Okay. Visibility is the pub setting here the public and returning the value string value. One more function is the set function. So in the set function, we are setting the value with the input argument that is of the string argument that is underscore value, and the state value or global variable is like value. So we are setting this value using the set function, and there is no return type in this set function. Okay. Okay, so the visibility is public here. So now this one is the constructor function. So what is the constructor function? The constructor function is when we deploy the smart contract. When we deploy the smart contract, then we have to fulfill all the conditions defined in the smart contract, and this constructor function is called when we deploy the smart contract. Okay, so first time when we deploy this constructor function is always called once when we deploy the smart contract. After that we can't call this constructor function. Okay, and the keyword used here is the constructor. Okay, and the visibility of this constructor function is the public in visual. By default, we may assign it as an internal because this one is called once during the life cycle of the smart contract. Okay, so we are setting here default value with the my value here. Okay, so this one is a state variable named visibility is public value and the value is my value. Okay, so this one is accessible outside the smart contract. So outside the smart contract means this the visibility is public, so anyone can check out the value of this smart contract. So if any variable is of public type, in that case there is no need to use the get function to fetch the value of that variable. By default, getter function is introduced when we define any variable as a public. So there is no need. We can define here at a constant. After that, no one will be able to update this value. So if we use the constant value, if we use the keyword constant, in that case we can't update the my value. So in that case there is no need to use the set function. Means that is already fixed and no one can alter the value of this constant. So there is no need to set. If the value is public, then in that case there is no need to use the get function. Okay, so what are available data types in the Solidity language? So first one is uh, Boolean data type. So in Boolean data type, it stores either true or false. So public is optional here. Either by default is the public, but we have to explicitly define the visibility of each and every variable. So this one is a public here defined here. The size are like similar to other programming basic programming languages like C, Python, and so on. So concepts of Boolean, integer, both are the same here. Okay, so signed integer in this Solidity is defined like integer with the public visibility. Name is my integer, and we are setting the value with the one. Okay, so this one is the here this one is integer, so integer can be either positive or maybe a negative. And so the default range for this integer is 256 bits. Keep in mind, again I am repeating, the range of this integer is in the 256 in bits. Okay, this one is the size of the integer. Okay, so there is one unsigned we can also use unsigned integer where we use int with unsigned. Okay, the syntax is uint, then public with my uint, and we are setting the value is value 1 here. So here the default size is 256 bits. Keep in mind 256, but explicitly we can define the size of the bits in our smart contract itself. So if we write here u in 256, in that case the size of the integer will be of the 256 bits. Okay, and we can store the size up to, means that we can store the value up to 2 raised to 250, maximum of the 2 raised to 256 in this 256 minus 1 in this uint my uint 256 variable. So if we want to assign the size of 8 bits, then we can use uint 8 with the public, and my int size is 8 bits, and we are storing here 8. So restricting the value to 8 bits. Now keep in mind that in the Ethereum blockchain, when we use any variable, then we have, if I, for example, if I am using uint 256 and I am storing that value to the blockchain that persists entire for a long time, means permanently persist in the blockchain itself. In that case, I have to pay the fees for that much of space. So U in 256 will consume the space of 256 bits in the blockchain itself. So as we choose the as larger we choose the size, as large as much as we have to pay the fee in the ether. Okay, so we have to use the minimal size. The major disadvantage of the blockchain is again the scalability or the size issue is there. So blockchain type, any type of application that is sustainable with the blockchain if we are using the limited size. So new data type is the address data type. in here. So in address is 256 bytes. Address is 256 in bytes in Ethereum. So here we have defined, sorry, address is 20 bytes in the Ethereum. Okay, and the here the variable name is X. With this holds the 0x defines hexadecimal with 212 and so on. This one is the hexadecimal address. Okay, so address, my address equals to this. There are two types of variable address. One is X address, second address is my address. Variable name is my address, so equals to this. So this one is the contract instance, so at which address this contract is deployed. So this one is the address of the smart contract. Okay, so address data type, there is one more data type, that is the address data type. So here, one script is written here that if the x dot balance is less than 10, it means if x is having less than 10 ethers and my account dot balance contain, sorry, this one is in WEI, WEI, that is the unit of subunit of the ether. Okay. So if my address dot balance is greater than 10, then you have to transfer 10 way from x from this contract instance of this to the x. Okay, so we'll check out how the balance will transfer here. So this one is basic idea about the address data type. So okay, so there is one more enumerated kind of data type as in C here. In C also we can define, we can enumerate the data types like state is the variable name that contains three values, three values like waiting, ready, and active. So here the variable name is the state, and it can hold only three values, either waiting or ready or active. So this one is user defined data type here. So to first we have to define the data type enum state, and then we have to make as a variable. So our data type name is capital state. S is capital here. When we check out in next slide, means next line, then this one is the small s. So small s with state with small s is like variable name, and this capital S is like data type, and the visibility of this function is the public. Okay, so what we are doing here, we are defining one constructor here with the public visibility with the state equals to capital S state dot waiting. So this state variable can hold only either waiting or ready or zero. In background, the size of this variable means the size of this variable will be 2 bits only, because there are three arguments here. So in 2 bits, we can define 2 raised to 2, means 2 raised to 2 is 4, that is less than this three values. So only 2 bits will be used to store the value of the state variable. So this one is the advantage of the enum. If the range is limited, so that we can range is limited and the values are fixed, so that we can use the enum and then can store the value to the enum. Okay, so next is we are converting our state from waiting to the active. So we have created one function named active here. So active is a function name with the visibility public, and we are changing the state from waiting to the active. So state equals to state dot active. So we have to call these functions. Okay, so next is enum, where if we are checking here, one more function is there in which we are checking either this state value of the state is active or not. So this function is named as is active, and there are two words, one is public, one is view. Okay, and there is one more word that is return. So return we have discussed, this one is the return type of this function. So here boolean is the return type of this function, and public is the visibility of this variable. So public is the visibility of this function. Okay, and if the current state is equals to state dot active, So is this function, if the state is in the active state already, then it will return the true value. Okay. So this one is one example that we have all three functions have discussed here. So you may note down this like contract here named my contract with one variable that is state variable, and this contains the three public state variable, and the data type is capital state. So this contains three values: waiting, ready, and active. So first, when we deploy the smart contract, then constructor will automatically be called, and this will be called once, and this stores the value waiting in the state variable by default. Okay. So when we call the function active, in that case, state dot active will be there. Means state dot active will be we are setting here the value of this state variable is as active, and if we want to check this value either active or not, so if we call the function is active, then it will check the statement state equals to state dot active, both are equal. In that case, this will return the true value. Okay, now next is like struct and array in the step. So now first we have to test these two sample codes. First one was the to set and to get the values, and second one is to check either state is active or waiting in the state. So first we have to now I have to switch the screen. Okay, so first share, then stop sharing. This time we have to move to the remix ID now. So this one is our remix ID. Okay, so this one is our earlier code. We were working on that code. So now I have to change the background with the white color theme. So we can change the theme of this browser itself. I think now it's better for all of you. Okay, so here contract name is simple storage with u in, there is one data type u in, this one is private data type, and variable name is stored number. This one is the constructor, this one is the setter function, this one is the getter function. Okay. So first, what we have to do, first we have to compile the smart contract. This one is correct. If there is any error, then on the down bottom side, the error will be shown here. We have to debug our smart contract and rectify the error. After that, we have to deploy the correct smart contract. So after compilation, we have to deploy the smart contract with estimated fees. So this need one argument because in the constructor function, initial value is required here. So I pass the value one, like 1, 2, 3, 4, and I deploy with this value. So this smart contract is correctly deployed to the blockchain. And when I check out, this one is the deployed smart contract to the blockchain at the address at 0xDB and so on. Okay, so I have to copy this address, and we will work this on this work address after some time. Okay, so there is two functions. One is the set function, and there is one more function, that is the get function. Okay, so in the deployed smart contract, as there are three functions, first one is the constructor function, second one is set and get. But keep in mind that this constructor is called once when we deploy the smart contract. So this has been called when we deployed the smart contract using the deploy. Okay, and after that this deployed smart contract can be accessed with this deployed contract. There are two functions only. If I get the function, if I call the function get function, that will return the value of the stored number. Okay. So here the value of the stored number is the initial value, that is the stored value, stored number. And if I set the value to 1, 2, 3, 4 to 5, 6, 7, 8, any value I can set within the range of u in 256. So the range of 256, so that I can assign a larger value, and that should be in the range of 256 bits. So if I call this with this value, then the new value will be set. Okay. When I check out this, then the new value, case limit, and debug code, and so on, this value is stored here. When I call the get function, so same value is again retrieved here. Okay, so this one is our set and get function. I think this one is clear to all of you. If you have any doubt, you may ask. During this, you may raise your hand if you have any doubt till now, so that we will move to the next smart contract. Although either, so anyone, okay, so okay, I think I have to move forward for this. So next one is like I think set and get function. So one more thing. By default, there is the get function. If I delete this, means if I delete this function, okay, okay, and the variable should be in the public. Okay, if the variable data type is the public data type, so in that case there is no need to use the getter function. Okay, so I have set the variable with the public and I have deleted the function get function. Again, we have to compile the smart contract. This one is correct. Then we have to deploy the smart contract with the initial value with the constructor. So initial value is again 1, 2, 3, 4, 5. Deploy. So there are two. Now there is the instance of the smart. There is new instance of the smart contract. So this one is the older simple smart contract at D8. This one is the older. New one is the at D7. So there is one more instance of this new smart contract in the blockchain itself. So a blockchain may contain multiple smart contracts. Okay, if I copy, means if I check out the smart contract, so there is again automatically getter function with the stored number. In the earlier example there was the get function, and in newer example, new example deployed smart contract, variable name is the stored variable name is stored number, so getter function is automatically created here. Okay, so this one is our when I call again, I have set the value with the 1 2 3 4 5 this time. When I deploy with the 1 2 3 4 5, when I call this, then 1 2 3 4 5 is saved here, because during the compilation I have passed the value 1 2 3 4 5 up to 5, and using the set value that is like 6 7 8 9, then I click the set value. In that case, now the new value is 6789. Okay, so by default, if the any argument is set as public, sorry, is any variable is set as public, in that case the getter function will automatically be created. Okay, so one more thing, if I delete this constructor variable, sorry, constructor function, so there is no constructor function. Okay, now again I have to test the smart contract with this environment, and I have to compile the smart contract. This one is the correct smart contract. I have to deploy this. Now this time when I deploy, then there is no required argument here. Okay, so earlier when the constructor is defined, in that case there was one box in which we have to pass the argument, that was the stored number. But this time there is no argument, because I have deleted the constructor function that was taking the argument. So simply I deploy the smart contract. Okay, so now there will be one more instance of the smart contract here. Okay, so when I click on the store number, I this should be the 0, means null value should be the here. If I update the value 1 2 3 only, if I set the value and I get the value, this one is the 1 2 3. So keep in mind here, I have deployed 3 instances or 3 different smart contracts to the blockchain, and all are deployed to the different addresses. So this one is deployed at the DA0 and so on. You can check out here. That is of DA0B and so on. This one is the address of the smart contract. Okay, and from will be the same all for all cases. from address will be the same. Okay, I think this one is 5b is our address. So if I check out 5b is our address, okay. So every time the fee will be deducted from our smart our account. Now our current fee balance is 999 and last is 003878. If I deploy one more instance, if I deploy last words are like we have to check last words are like 3878 na. Now I have to deploy one more instance, deploy 3878 was there. Okay, so I have deployed one more instance. Now my balance is changed, that is reduced. I have paid some more ethers, means in way I have paid more ethers in way to deploy the smart contract. Here deployment is the again the deployment is again here one transaction here. Okay, now okay, so now there are three instances. I am working with either I am working with this instance or with this instance or with this instance. So in blockchain, all entries will remain. Okay. If I communicate with this, then the get value will return the value 5678. If I communicate with the instance stored at D7, then the value is 6789. If I communicate with DA, then the value is 1234. If I set the value, I can call any function 56564545. Sorry, first the set value and then get value. Every time I am paying the fees when I deploy the when I initiate a transaction. Every time I am paying the fees and fees deducted from my account here. So this account balance will be reduced again and again every time when I call a function and I initiate a transaction. So every time the fee will be deducted from the account. And now there are multiple instances of different smart contract. Every time when I deploy one smart contract, then one instance will be created to the blockchain itself. Okay. So next to our slides, add view function to access state variable value. Okay, there is one question from Ravindra. Okay, so add view function. Okay, so view function we have discussed, like if the function is view kind of there, view function will be there should be the set function. If that is set function, then should be the error. If I define a view function, okay, we'll discuss on this view function again. So I have added view type of this function, and but we are updating the value. Okay, so if I compile the smart contract, so there is one error like function cannot be declared as view because this expression potentially, like we have some error like this function should be the view. So if the function is of the getter function, for example, I think I have to modify using project only. Okay. So this one was let me I think this much of space is here only. Okay, so what I have to do, I have to just copy and then define one more function set, and the name is the get function. And get function doesn't take any argument here, just public and then view. Okay, okay, and we are just return type is like we have to define the return type. Return, and that returns u in, okay, that returns u into 56 to 56. Okay, so this time this function is the get function without any input argument with the return like return u in 56. Okay, okay, there is a error here. returns. That word is the return. Sorry, pardon my mistake. Okay, so that word is returns. Okay, so returns the value of return the variable u in 6. Okay, so I think this time it's a return stored number. There is no need to assign the value. I am just returning the value. This one is the return type. So we may use the constructor, we may not use the constructor. This time this one is the correct. Okay, I think. So first we have to compile this smart contract. Okay, there is one warning here. Although this one has been compiled here, but there is one warning. So scam alert. So there may be some issue with the code. The unnamed variable uint remains unassigned. So we have to be initial value and we are calling it. Let me try this. Okay. So when I deploy this smart contract with the set, first we have to again we have to compile the first we have to compile the smart contract. We have to deploy the smart contract with the initial value 1 2 3 4 5 6 7. Then deploy instance will be there, and if I call the get function, so last instance, why it's not getting stored variable, stored number is the issue with this. Okay, constructor stored value, initial value. Let me update the code again. Okay, okay, this one is correct now. Okay, so this one is again view type. Okay, so here we are not updating the any value, and if we delete this constructor value, there is no constructor function. This one is the public argument. Although there is no the automatically getter will be there. If I compile this one is the correct, and when I deploy this compiled instance, I have to delete, which makes confusion. So I have deleted all the deployed instance. Okay, so there is no deployed instance in this smart contract, in this ID itself, and now I can deploy. There is no constructor function, so there is no argument is required for the deployment. When I click on the deploy, the instance is deployed here, and this set function is from this set function, this get function is from this get function, and this stored number is always as this one is the public, so this one is from the getter from default getter function. Okay, so this time when I set the value I set, and then I get the visibility is view here only, so there is no updation. Okay, if I define view here in this function we view, in that case there will be error. When I compile, then there will be error. This will not the compile code, there will be the error. This. Okay, okay, now there are some doubts. No, we can't modify state variable using the, yes, no, yeah, yes, we can't update the state variable with the view function. Exactly correct. I am talking about the get function. Get function is the view function. There is no issue. It can be deleted from, I think I am slightly delayed with these comments. Okay, it can be declared get function as view function. Okay, so this one is the smart contract with several functions. We'll discuss the view and pure. There are two functions. First one is sorry, there are two visibilities like view and pure. So where to use the view and where to use the pure. So view is used to just access the state variable, and where pure is again again have some more construct on the view variable, that is the pure, where you can't access even the state variable. Okay, so we'll see the example in the next slides. Okay, so now there was one more example of the enum. Should I cover that example? I think I have to skip that example because due to the sake of the timing period, actually there is lots of content in this PPT. Okay, so we'll try to best to deliver our content so that you will be able to move forward. Okay, I have to switch this from Remix ID to presentation again. Application is like, okay, sure. Okay. So this one is one more example of changing the state with the using the enum variable. Now next is the struct. So similarly in the as similar to the C programming, we can also define the struct here. So in struct we have defined two variables. Like the first is a string variable that is of first name, and second string is like last name. So there are two variables and data type is the capital P person. Okay, so we have to, this one is the structure of the variable person, and as shown here, variable name is the people's. So like visibility is given here as public by default, so anyone can access this array of this people person array. Okay. Uh, so there is now currently just we have defined the struct with the two variables, and declared one array with the of type of person named people. Okay, so the indexing will be same as in the C programming, like 0, 1, and so on. Okay, so how to add the, like how to add the values, to push the values to the array itself. So the method is like, again there will be one function named add function. Means you may use any name for the function name, as like similar to the C programming or another basic program standard programming languages. Okay, so function name is add person, and this one is taking two arguments, first name and the last name. These are the string with the keyword memory. So what is the meaning of this memory keyword here? Is like memory keyword is basically a temporary keyword. Like uh, if we use the permanent storage in each and every variable in the blockchain itself, then we have to pay the fees for each and every variable. So this memory keyword is the temporary keyword that is runs that is used when we run the smart contract on the EVM itself. EVM means the Ethereum virtual machine that runs on all the codes in that blockchain network. Okay, and this visibility of this function is again public. We are pushing the data. We are pushing the data to the public people array of the person. Struct is the person struct. Person is the data type with the two arguments. We are pushing these two arguments to the people array, and we are using the push. So there is one more variable that is people count. Although we have not defined this people count, so we have to define also this people count before using this people count variable. Okay, so in next line this one is defined like u in 256 is like here push is the push keyword is used to add the value to the array itself. So there is either there may be the array of the, there may be the array of the this person data type, or there may be the mapping of this person data type. So here this example is the array. We'll see the example of the mapping. Okay, so here the in the previous example here we have defined one more people count that keeps the counting of the persons in your smart contract. Let me check if there is any. Okay, I think the screen is up to you. Means PPT mode is open. No? Just verify that I'm going right or not.
Yes, sir.
Okay.
PPT slide even.
Okay, okay. So next one is like this one is complete example of the struct and array. As shown here, we have defined one struct, and with the array of the that struct person named people, and there is one people count variable. We have defined one person with the add person. Okay, and the string. This one is taking two memory type parameter, first name and last name. We are pushing the to the person array, and we are also increasing the. So we have to also one more thing, we have to initialize. By default this one value is of this u int 256 is 0, but for the safer side we may initialize this value as the 0. I am is supposed to be all the participants have the basic knowledge about the C programming language, so that they it will be easier for all of you to work smoothly with the this smart contract. Okay, so next example is like of the mapping. Earlier was structure with the earlier was structure with the array, and this one is structure with mapping. Okay, so again there is one more mapping. There is one more mapping, like this one is the structure. Okay, so um, okay, so this one is the structure. Okay, and this one is the mapping. Okay, so this one is a people count initialized to 0. Okay, and here this one is like mapping name, and the mapping is from uint data type to the person data type. Okay, so mapping is from uint to person, and mapping name is people. And the method to add the data to this mapping is like, first we have to pass the uint, and then we have to pass the person. So mapping, we have created one mapping with the people. We are pushing the data people, then people count will be 0 1 2 3 onwards. Person, people count again we are using here there, so there is no, either we may use here, means this one is mandatory, and we may store here. This one is the key of this this mapping. Okay, and this one is a works as an index. Okay, so this index we are using means sequence number. At this sequence number we are using first name and the last name. Okay, so okay, so this one is the example of the mapping. Okay, so this one is mapping. We are mapping to person with the integer, with the people name, with visibility public. Okay, I think this one is clear to all of you. Let me check on the chat box. So there is one question, sir. What is meant by mapping here? Please explain. Okay. So mapping is like in Python we have dictionary kind of stuff there. So there is one key pair, means like from which key to we are like. Let me explain here. So first there is one table here. So this one is the key. Okay, and this one is the data associated with this key. Here our data is data type is person. So either I have to write here person, and the name is people. Okay, and this key is here uint. Okay, so we are mapping here from this key 0 index to, like, if I call the function add person, with the first name is like I use my name like Jitendra is the first name, and with the last name Goyal, and so on. So with at this index, Jitendra Goyal is there. At index one, our host Mr. Agam is there. So AZAM Agam, and I don't know the surname, but I'm using Kumar. If there's Agam Kumar is there, then second. So this one is the mapping. Okay. So mapping from this index to this data type. So our person wrote this. This one is our mapping of person data type named people. So this entire is the people. Okay. Uh, Actually, I am the writing is not so clear here. So please, sorry for this. For this writing on the writing pad. So the mapping is like this. This entire is the mapping with this uint. This uint is this one, and this person is this one, and this people is this entire stuff here. Okay, and this one is the mapping concept, and we are pushing, we are means we are increasing this people count. Now keep in mind that I have incremented this one before executing this transaction. So this will be first, this will be 1, this will be 2, this will be 3, and so on, not 0 1 2. If that is below the statement, then in that case only it will be 0, 1 and 2. I think now it's clear. Okay, thank you sir. Okay, so now next is like function visibility. So already we have discussed the public visibility that is accessed outside the smart contract. Okay, so this one is the outside the smart contract. If we define it as inside the smart contract, so directly a word come in my our mind is like that is the public keyword. But there is one more like private keyword. So inside the smart contract itself, we use the internal keyword. Okay. So in earlier example, this person count is incremented within this people in function add person itself. Okay, and in this example, we have defined one more function that is increment count. Okay, so and the visibility of this in is visibility of this function is in internal type. Okay, so this function increases the value of this people count. So next, what will be here? There will be nested function call of the increment. Okay, so this one is the again function call of the increment count, and which one is this? So this one is this function. Okay, so again mapping is same here. People count. Okay, first we are incrementing the value. It depends on you, either you pre means increment before the statement or the after this statement, and we are adding this to this index value, this key value. This one is uint value, uint 256, with this id, with this first name, and with this with the last name. Okay, now next is the modifier. So what is the meaning of the modifier here? So modifier is like in the Solidity programming language, we can also define the modifier which provides the right or provides some storage value to use within the smart contract. We apply some constant on the smart contract itself. So here the modifier data type is address data type, and the modifier name is like variable name is like owner. So I have created one constructor. I have created one constructor that stores the value message dot sender within this variable owner. So owner is the address data type, and message dot sender returns the address of the sender. So who will be the address of the sender here? Who will call this contract? Who will call this constructor function, and who will call this function? Who will call this constructor function? Who deploys the smart contract, because constructor function is always called once in the smart contract, and that is called during the deployment of the smart contract. So the owner of the smart contract, when he deploys the smart contract to the blockchain, so automatically the address of this message dot sender will be stored to this blockchain, stored to this owner variable. So this owner variable stores the address of the deployer. Okay, so next one is uh, okay, we have discussed this. So our modifier name is only modifier. Our modifier name is only modifier requires that message dot sender should be equals to owner. So what is it mean is like if if any in any application or in any smart contract, if we want to only give the right to the owner only, like adding the participant, or like adding the question or something to the owner itself, so we have to define the modifier like only owner. Okay, we'll see how this owner will work. So I have declared modifier here and checking the condition that message.sender should be like message.sender should be like equals to the owner. So here owner will be set when we deploy the smart contract. Okay, so now see in this example here. Okay, so first thing is first this one is our struct function. Okay, we have discussed the struct function. We have created one mapping of the struct function with the u in 256. Now there is one constructor function owner. So during the deployment of the smart contract, this owner will be set up as a message dot sender. Okay. Now next task is to add. Uh, there is one more function that is increment count. We have already discussed this increment count. Now next is modifier. We have defined one modifier during the deployment, that only modifier will check the condition if requires like message dot sender, the value of the message dot sender should be equals to the owner. So every time who calls this function will be the message dot sender, but who is the owner? Who is the owner? Owner is here the deployer of this smart contract, deployer of the smart contract, or the owner of the smart contract who deployed the smart contract. So owner holds the value of the uh, address of the deployer. So when we define the only owner modifier, only owner modifier. So only owner modifier, this one is our modifier we have defined here. Okay, so only modifier, and we when we call this function, so this condition must be true. Okay, and what is the condition? Condition is like this modifier must be true, and that requires message dot sender should be equals to owner. So if owner of the smart contract, if the owner of the smart contract calls this same function, then he will be able to call this function or to add the person. Otherwise, he will not be able to add the person. Okay, like means you can't call this add function. In earlier example, anyone with the smart contract can call this function, but here there is one modifier named only owner, so only owner can modify this smart contract. Okay, I think it's clear to all of you. Is there any issue or doubt? Okay, so let me forward next. Okay, so our next is time stamping. So if we are willing to write a smart contract, so smart contract, we state that now we have discussed like how to write an application, how to store the value, how to call the function, and so on. And these are the applications. So if we generally state that Ethereum or any blockchain is decentralized in nature. So any piece of software or piece of code is written in the blockchain itself, that is used, that is work as a legal agreement between two parties. Means if you means legal agreement means what is the agreement? Agreement is like if you give this, then I will give you this much of amount. If you do this, then I will give you this much of amount. After the 5 p.m. this will be after the 5 p.m. the keys will be open. After that 6 p.m. or the at 6 p.m. the keys will be closed. So there the standard code piece of code should be there. Okay, so now there is for example, if either quiz management or at a fixed time registry management, if we want to apply the time stamping in our smart contract itself, so we can use the timestamp. If there is any this one is transparent, blockchain is transparent. The smart contract, deployed smart contract is publicly available to all of you, so anyone can check that smart contract, and all the operations will be done on the behalf of that written smart contract only. So there is no in centralized authority, banking can update their software. Like if you are using ICICI Bank or any bank, so bank can update their software and then they can change the policy. But in the case of the blockchain, once the smart contract is written, So no one can change that smart that code, written code, and that the party or that owner has to be rely on that code itself. Okay, so we may check out that code, and that code persists, that code remains lifelong for the execution there. So for example, there is one example of like if there is any sale of there is discount sale, one organization is showing that we are floating one sale. If you buy on this from this platform, then you will get this much of amount after the result will be declared on 20th of the July, 20th of the June, and so on after the completion of this FDP. So how will you rely on me? So what will you do? You will check our smart contract where the smart contract is written there. So you will verify is the statement is true or not. After that only you will apply your money, your fund to the blockchain, or you will store something, or you will do something with that smart contract, or you will interact with that smart contract. That is publicly available, that is transparent, that is not alterable. Okay, so this one is promotion, but either I have to rely this or not rely. If that is on Ethereum blockchain or any public blockchain, we can check out the source code of that shell, or that quiz, or that winning that lottery system or so that is publicly available. So we can check out that smart contract. So this one is the concept of the timestamp, how to apply the time stamping in our smart contract. Again, I think now you are familiar with this constructor and the variable type. So I have defined one constructor with the start time. In this start time is like 1769 and so on. So in this Ethereum blockchain, this smart contract is like sorry, this timer is stored in the Unix format. Okay, so what is the Unix format in Unix? This one is 0 GMT from since January 1st of to 1970. Each and every second is counted, means the number of seconds from 1st of Jan 1970 to till today, till this point. Okay, that will be the time of the current time. Okay, so this compiler converts this number of seconds to the timestamp exactly. What happens means time is stored in this Unix epoch format. Okay, so I have stored one variable that is start time. Actually, this one is a variable, start time variable, and we have defined the start time variable u 256, and the on while open. This means after this time, this cell or this quiz or this permission will be available to all of you. So we have created one modifier that only while open. Okay, and that requires block dot timestamp should be greater than equals to the start time. So like I have set the timestamp morning 9 p.m. Sorry, morning 9 a.m. Okay, and start time is 9 a.m. in Unix. The number of seconds till today 9 morning will be stated as the start time here. And if I perform this block dot timestamp, will revert you that at which time this block will be mined. Okay, so this block timestamp is the timestamp of the mining time of the block. If that is higher than this start time, at that time only the stars will you will be able, means this deployer will be able to work with this. So what happens here? The constructor with again message or owner message dot sender here. Again only means this task can be done by only by owner. Okay, so there is one modifier only owner. There is only owner is added, means add person can be done with the help with only by the owner itself. Then there is start time also defined here. There is one more modifier only while open. So this only while open is like there is one more timestamp should be greater than the defined start time. That is deployed to the smart contract. It means this code, if this code is already deployed to the smart contract, you check out the smart contract. If you relies on this smart contract, and you are agree with this agreement, you are agree with the smart agreement, smart contract, smart agreement, or a piece of code, or a program, or a application. Okay, so if you are agree with this smart contract, and you rely this smart contract, then you will interact this smart contract, and you will pay your money or something else. So only modifier defines that after opening of after this time, the owner will be able to add the participants or add the persons. Okay. So here the struct is not defined here. So this one is, I consider that struct is already defined like this. Okay. Okay. So uh, there are two modifiers, only owner and only while open. Okay. So in this, after 9 a.m. only, the person will be able to to register it, means owner will be able to register some participants. It may be like if there is no only owner is removed here from here, then any person can register after the 9 a.m. Okay. If there is one more modifier that only till open. Okay. And there is one more modifier, and that is end time defined here. If end time is also defined as 9 p.m., then modifier is only while open, one more modifier like only till open. So within this time window, the person will be able to register them himself. Okay. And this condition may be only may be applicable if one more only owner is also defined. In that case, only owner will be able to do this task. Okay. So like if there is any question or your screen, you are on the screen, no screen, not getting. Okay. uh, your screen, no, your screen, please share your screen. I think screen is visible, Mr. Anurag. Please, Agam or anyone, let me know. Is there?
Yes, sir, it is visible.
Okay, so because there is one doubt from, I think there is issue at this. Okay, okay. I think some participants are getting my screen, so I am supposed to be. This one is there is a correct operation going on. So next is like I think last time is 110, na?
Yes, sir.
Okay. Let me move forward some more slides also. Actually, actually there is lots of content. There is one more. There will be one more session or hands-on session on this Solidity language and compilation of the smart contract on means tomorrow and on the next day. Next 2 days will be on the hands of kind of work will be there. Hands of lab will be there. Okay, so there will be some more advanced features of the Solidity language. So we have discussed scope of the variable like public, internal, and private. Public is basically available for both internally, externally purpose, externally available. Internally is only available to that within the smart contract, or if a smart contract is inherited from the parent contract. So the functions that are internally assigned can be accessed by their child contracts. Okay. So private is only accessed within that smart contract, as similar to the C++ programming concepts. Okay. So internal, like as shown here, there is one parent with the variable name internal. Okay. So parent is the parent is contract, and child is one more contract that is inherited with this is keyword. Okay. And okay. Okay, so child is in a child contract is inherited with this parent. This is keyword with the parent smart contract. So you can access this internal variable that is secret number, and you can uh, check out. You can work with this internal. This one is get secret function. So within the smart contract or the contract inherited with the smart contract can use this internal keyword. So this one is one example of the internal. This one is the example of uh, internal keyword here. So let me. Okay, highlight will be the better. Okay, so There is one variable, public variable. Okay, so one more variable, that is internal variable. Okay, so this is the one function that is accessing the public variable. There is one more contract. So this one is the C contract, this one is the caller contract. Okay, so public variable can be accessed publicly by any another contract within any other contract. So we have created one instance of this contract, new instance of the C contract, and there is one function, and we are accessing the data C dot data. Okay, so we are accessing externally this contract, and we are accessing this public data. And for the internal, this will not be applicable. If we use here I data, then we will not be able to access the I data. But if we inherit, if we design one more contract D with the with the contract C, inherited with the contract C, and there is one function Y function, and we are accessing the internal variable, internal data type. The visibility is scope of this variable is internal, so we can return this internal data type. Okay, so this one is the concept of the internal and the public. Internal, public, and private. If the data type is the private data type, in that case the data type only be accessible within this parent smart contract, this own smart contract. So next is the memory keyword. Okay, so memory keyword is like we have already discussed. When we use the memory keyword, so memory keyword doesn't consume the space on the blockchain itself. This one is used only for the the space is only used during the execution of the smart contract. So these are the temporary environments. These are the temporary variables. Sorry. So we have to use memory keyword in the function memory. By default, the value is default location, storage location is the memory storage location. Because in the Ethereum blockchain or in any public blockchain, for every kind of transaction, we have to every kind of storage we have to pay the fees in ethers. So the storage should be minimized. Okay, so this one is the example of the view function. So view function simply used to view, here we are using this view function. So only we can access we can view this function. Okay, so this one is one example of there is one public variable x. This one is the view function, and this one is the pure function. So let me change to this. So there are two function add to x. There is one more function add. Okay, and the variable name is public x. Okay, so view function is just used to view the value of the state variables. Here x is the state variable. So x plus y will be returned, but the value of the x will not be modified here. Okay, we are just returning the value x and x plus y. if we use the pure if we use the pure keyword instead of view function, in that case, we even though we can't read the value of this x also, if we use x here, then there will be some error during the compilation time. Okay, so this pure is more security oriented functions with compared to the view property. Okay, so state, this view only reads the state variable, doesn't modify the state variable, but but this pure function not only does not read and write the state variable. Okay, so these properties are defined to enhance the security of the smart contract. If the function is the pure function, so in that case, that will not be so the caller of this function will not be able to access the state variables. Okay, so I think I should stop here. Like sending and receiving the ether, I give you some glimpse. Like there are three methods to send the ether to from one account to the another account. like transfer, send, and call. And there are two methods to receive the like there are two methods to receive the ethers. Like first one is the receive and second one is the fallback function. By using these receive and send and transfer, we can transfer and receive the ethers and use as. But for those cases, the function should be the payable function. Okay. One more word, the fallback functions. What is the fallback function? If we call any function in the smart contract, and if there is argument name is not correct or name is not available there, so there should be one default fallback function that will be called when the definition of the function doesn't match with the calling function. Okay, so generally when fallback function is used to receive the ether, so a script is defined in the fallback function itself, as shown here. This fallback function, the wording is used as a fallback that should always be external. The reason is like always this function is called is called when external party calls this function. Okay, so if the definition doesn't meet with any another function defined in this smart contract, in that case this fallback function is called. And if you are receiving some ether using this fallback function, then that should be always be the payable. Okay, so I think we should stop here. Okay, so now to all the participants, is there any queries or any doubt, you may ask in the chat box, or if is it possible, you may raise your hand, and then Mr. Agam will give you the right to unmute you. Okay. Is there any question or any doubt you may ask in this chat box? I request Mr. Agam to unmute if any participant wants to ask, or if sure, Swaroop Rani. So thank you so much. My mail ID is like jitendra.goyal at bitmishra. And also you may reach out at erjgoyal. And if you are facing any issue, then you may also contact via phone also. You just drop one message so that like I will connect with you in after checking my schedule and so on. That will be feasible, that will be good for both of us. So if I have spare time, then I will give you proper time. Okay. Okay, so there is one more suggestion for you. There is a solidity solidity documentation is there. So let me share my screen again. Okay, so share, stop sharing screen, and then which one, this new tab, and then share. This one is like solidity documentation. Okay, so there is a doc file for the solidity. So solidity introduction of the solidity and examples, basic of the blockchain, the transactions, variable, global variable. Like there is good documentation given here. So that may be the helpful for all of you to go deeply inside this solidity language. Okay, so how to define the contracts here, creating the contract, So address data type, byte 32 data type. There is one constructor function with setting the value with another function name, checking the condition and so on, how to define the function, for loop, if condition, etc. There are lots of stuff here you may use for like your. Okay, now I think I should leave. I request Mr. Agam if there is any question or any doubt, I will provide.
So I think there are no more queries, so we will further proceed. So thank you, sir. Our deepest gratitude for truly enlightening presentation on smart contracts and Solidity programming. Discussion on Solidity language and practical demonstration using tools like Remix truly broadened our understanding. Thank you for your valuable time and truly enriching sessions.
Thank you, organizing team, to inviting me for this FDP again.
Thank you, sir.
Okay, thank you.
So there will be 40 minutes break. We will be again meeting at 1:50. So be here at 1:50 p.m.